As you gently settle into this moment, imagine yourself drifting quietly through the vastness of space, feeling the serene embrace of the universe around you. Welcome to this journey of wonder and exploration, where together we will uncover the mysteries of our cosmic neighborhood. Our story begins with a simple but profound question. Why are some planets rocky while others are composed of gas? To understand this, we must first embark on a voyage through our solar system, a collection of celestial bodies bound by the gentle pull of the sun's gravity. Picture our solar system as a grand celestial tapestry, woven together by the invisible threads of gravity. At its center, the sun radiates warmth and light, its immense mass anchoring the planets in their orbits. Each planet follows a unique path around this luminous star, creating a harmonious dance that has persisted for billions of years. Our solar system extends far beyond the planets we can see, reaching out into the depths of space with a boundary defined by the sun's influence, known as the heliosphere. Here, solar winds meet the interstellar medium, marking the edge of our solar neighborhood. As we begin to explore this cosmic arrangement, we start with the planets closest to the sun. These are known as the terrestrial planets, composed primarily of rock and metal. Mercury, Venus, Earth, and Mars form this group, each with its distinct characteristics and history. Their proximity to the sun plays a crucial role in their composition. The intense heat from our star caused lighter gases like hydrogen and helium to be blown away during the early formation stages, leaving behind denser materials to form solid surfaces. The terrestrial planets are small but mighty, their surfaces shaped by volcanic activity, tectonic movements, and impacts from celestial debris over eons. As we glide past Earth, our home, we marvel at its blue oceans and verdant lands, a testament to the delicate balance of conditions that sustain life. Continuing outward, we encounter Mars with its rusty hue and whispering winds, a planet that has captured our imagination as we ponder the possibility of ancient life in its past. Beyond Mars lies a vast expanse known as the asteroid belt, a region filled with rocky remnants from the solar system's formation. These fragments, too small to form planets, provide a fascinating glimpse into the early processes that shaped our cosmic surroundings. As we drift through this region, we are reminded of the dynamic forces at play in the universe, where gravity and motion combine to create the intricate structures we observe today. Leaving the asteroid belt behind, we approach the gas giants, beginning with Jupiter, the largest planet in our solar system. These planets, unlike their rocky counterparts, are composed predominantly of hydrogen and helium, the lightest and most abundant elements in the universe. Jupiter's immense size and swirling bands of clouds captivate our attention, its atmosphere a turbulent sea of gases with no solid surface to stand upon. This vast planet, with its powerful magnetic field and numerous moons, offers a stark contrast to the inner rocky worlds. Following Jupiter, we find Saturn, adorned with its iconic rings, a stunning display of ice and rock particles gracefully circling the planet. Here, too, the atmosphere is a swirling mix of gases, with storms and winds painting ever-changing patterns across its surface. As we continue our journey, we encounter Uranus and Neptune, the ice giants, whose blue hues hint at the presence of methane in their atmospheres. These distant worlds, cold and remote, are shrouded in mystery, their compositions revealing a different balance of elements compared to their larger gas giant siblings. The distinction between rocky and gaseous planets lies in their formation and location within the solar system. During the birth of our cosmic neighborhood, a protoplanetary disk of dust and gas surrounded the newborn sun. In this swirling disk, material began to coalesce, forming planetesimals, the building blocks of planets. Closer to the sun, where temperatures were higher, only metals and silicate rocks could condense into solid form, leading to the creation of the rocky terrestrial planets. Meanwhile, farther from the sun, where temperatures were cooler, ices could also condense, allowing for the accumulation of more massive cores that could capture and hold onto thick atmospheres of gas. As we contemplate this elegant dance of creation, we appreciate the delicate interplay of distance, temperature, and material that determine the fate of each planet. The gas giants, with their massive atmospheres, hint at the abundance of hydrogen and helium in the universe, remnants from the Big Bang that still linger in the cosmos. The rocky planets, meanwhile, remind us of the solid foundations upon which life as we know it stands, each one a unique world with its own story to tell. As our journey through the solar system winds to a gentle pause, we find ourselves gazing back at the sun, the nurturing heart of our cosmic family. Its light and warmth have shaped every planet, moon, and asteroid, weaving them into a harmonious system that continues to inspire and intrigue. Though our exploration has only just begun, we are filled with a sense of wonder and gratitude for the intricate beauty of the universe we call home. In the quiet moments between thoughts, imagine yourself adrift in this vast expanse, a silent observer of celestial wonders. The stars twinkle softly against the velvet backdrop of space, each one a distant sun with its own story, waiting to be discovered. The planets, our companions on this cosmic journey, continue their graceful orbits, each one a testament to the enduring power of gravity and time. As we pause to reflect on these mysteries, we find solace in the knowledge that the universe is a place of endless discovery and gentle curiosity. Floating in the serene embrace of the cosmos, one might wonder about the formation of these celestial neighbors, each sculpted by the subtle and mighty forces of the universe. To truly appreciate why some planets are rocky while others are vast spheres of gas, we must look back into the primordial mists of time, to an era when the solar system was but a swirling disk of dust and gas. This protoplanetary disk, a place of gentle chaos and quiet potential, harbored all the ingredients necessary for the birth of planets. As the sun ignited at the center, its radiant energy began to shape the destiny of the matter swirling around it. Closer to the nascent sun, temperatures soared, and in this cauldron of heat, only the heavier elements could coalesce into solid form. Here, in this warmer region, the terrestrial planets took shape, their rocky bodies forming from the accretion of metals and silicates. The lighter elements, unable to condense in such heat, were pushed outward, carried away by the solar wind. It was in the cooler reaches of this disk, far enough from the sun's fiery embrace, that the gas giants began their formation. In these outer regions, hydrogen and helium, the most abundant elements in the universe, could gather and form the massive envelopes of gas that we see today surrounding the cores of Jupiter and Saturn. Further afield, where the solar nebula was even cooler, Uranus and Neptune were able to capture not only hydrogen and helium, but also more ices, water, ammonia, and methane, adding a distinctive character to these distant ice giants. These differences in planetary formation zones underline the role of temperature and distance from the sun in determining the composition and nature of the planets. It's fascinating to think that the very position of a planet within the solar nebula could dictate its fate, shaping its atmosphere, its core, and its potential for harboring life. But the story of planetary formation is not just one of location. It is also a tale of time and the slow, deliberate processes that govern the cosmos. Over millions of years, the gentle collisions of dust and ice particles gradually gave rise to planetesimals, the building blocks of planets. These planetesimals, through a process known as accretion, merge to form larger bodies, slowly growing in mass and gravitational influence. In the inner solar system, these collisions were more frequent and violent, resulting in the rocky planets we know today. Meanwhile, in the outer reaches, where collisions were less frequent and more gentle, the gas giants were able to gather their expansive atmospheres. As we drift along this journey of understanding, it is worth considering the role of gravity, the invisible hand that shaped our solar system. Gravity, emanating from the Sun, not only holds the planets in their orbits but also played a crucial role in their formation. It was gravity that pulled the swirling gas and dust together, forming stars and planets, and it is gravity that continues to orchestrate the celestial ballet of our solar system. The interplay of gravity and motion has sculpted the solar system into its current form, a harmonious and dynamic system of worlds, each unique, yet part of a greater whole. Yet, even as we gaze at our neighboring planets, it is humbling to remember that our solar system is but one of countless others scattered across the cosmos. With the advent of telescopes capable of peering into the vastness of space, astronomers have discovered thousands of exoplanets orbiting distant stars. These worlds, diverse and numerous, challenge our understanding of planetary formation and composition. Some of these exoplanets are rocky, like our terrestrial planets, while others are gas giants and still more defy easy categorization, exhibiting characteristics that stretch our imagination. There are hot Jupiters, massive gas giants that orbit perilously close to their stars, and super-Earths, rocky planets larger than Earth, that might offer clues to the diversity of worlds in our galaxy. The discovery of these exoplanets has opened a new chapter in our quest to understand the universe, prompting questions about the uniqueness of our solar system and the potential for life beyond our planet. It beckons us to ponder what conditions might lead to the emergence of life, and whether the delicate balance that sustains life on Earth is a common outcome or a rarity in the cosmic expanse. As we explore these distant worlds, we are reminded of the interconnectedness of all things, how the elements that form planets and stars are the very same that constitute us. In contemplating these vast distances and the countless stars that fill the night sky, one is struck by the sense of continuity and infinity that the universe embodies. The same processes that forged our solar system are at work throughout the cosmos, creating and recreating in an endless cycle of birth, growth, and transformation. The elements that form rocky worlds, the gases that swell into giant planets, and the ices that compose the distant realms of our solar system are all remnants of the ancient stars that once burned brightly, giving us a glimpse into the cycles of cosmic evolution. As our journey through the cosmos continues, we are drawn to reflect on the remarkable resilience and adaptability of the universe. The planets, each with its unique characteristics, are a testament to the diverse outcomes of planetary formation. From the blistering surface of Mercury to the swirling storms of Jupiter, the universe reveals its boundless creativity, its capacity to surprise and inspire. Each planet in its own way offers a window into the past, a record of the forces and events that shaped it, and by extension, the solar system as a whole. Yet, while the planets hold many secrets, they also represent the future of exploration and discovery. As humanity reaches outward, propelled by curiosity and an innate desire to explore, the planets offer destinations for inquiry and understanding. They invite us to step beyond our earthly bounds to learn, to discover, and to appreciate the beauty and complexity of the universe. The knowledge we gain from studying these distant worlds enriches our understanding of the cosmos and our place within it. Thus, in this tranquil moment of reflection, we find ourselves connected to the greater cosmos, participants in a narrative that spans time and space. The planets, silent witnesses to the unfolding of the universe, remind us of the grandeur and mystery of creation. They are beacons of curiosity and wonder, inviting us to look beyond the horizon, to embrace the unknown with open minds and open hearts. As we drift gently through this cosmic tapestry, we are reminded of the infinite possibilities that the universe holds, each one a thread in the vast and intricate fabric of existence. In contemplating the vastness of space and the diversity of worlds within it, we find a gentle reassurance in the constancy of the natural laws that govern the cosmos. The same forces that sculpted our solar system operate across the universe, a testament to the unity of creation. This unity, reflected in the stars and planets, resonates within us, inviting us to explore, to understand, and to cherish the interconnectedness of all things. As we continue our journey through the stars, let us carry with us a sense of wonder and gratitude for the beauty that surrounds us. The planets, in their silent orbits, serve as reminders of the enduring power of the universe to inspire and transform. In their presence, we find both a reflection of our past and a promise of future discoveries, an invitation to explore the infinite possibilities that lie beyond our earthly home. As we drift further into the cosmos, the tapestry of planetary diversity unfolds before us like an ancient story written in the language of chemistry and physics. Each planet, whether nestled within our own solar system or orbiting a distant star, is a unique expression of the primordial forces that sculpted them. Yet, amidst this diversity, we find recurring themes and motifs, echoes of the same processes that once shaped our Earth. Consider, for instance, the delicate dance of elements that takes place in the birth of a star and its planetary companions. In the swirling chaos of a protoplanetary disk, where particles of dust and gas collide and coalesce, the seeds of future worlds are sown. These particles, subjected to the relentless pull of gravity, begin their journey towards becoming solid bodies, each one a potential canvas for the artistry of nature. In the inner regions of such a disk, where temperatures soar, only the most resilient materials, metals and silicates can endure. These are the building blocks of rocky worlds, stark and solid, their surfaces sculpted by volcanic activity and the impacts of countless meteoroids. They are the terrestrial planets like Mercury, Venus, Earth, and Mars, each one telling a story of its own. Yet further out, where the warmth of the nascent star fades and the environment becomes more forgiving, another kind of planet emerges. Here, in the chill of space, gases like hydrogen and helium, along with water, methane, and ammonia, can condense into solid or liquid forms, forming the cores of the gas giants. These immense planets, such as Jupiter and Saturn, are crowned with swirling clouds of gas and ringed with icy debris, their vast atmospheres extending far into the heavens. They are worlds of grandeur and mystery, their complex weather patterns and magnetic fields a testament to the dynamic processes at play within them. Beyond the gas giants lie the ice giants, Uranus and Neptune, their compositions rich in volatiles that were able to condense in the cold reaches of the solar system. These planets, with their serene blue hues, conceal beneath their clouds a landscape of ices and liquids, their atmospheres a frosty mix of hydrogen, helium, and methane. Though they may seem distant and inscrutable, they too are part of the same cosmic family, their origins tied to the same disk of dust and gas that birthed the fiery sun. As we contemplate these distant worlds, we are drawn to ponder the myriad exoplanets discovered in recent decades. These distant planets, orbiting stars far beyond our own sun, expand our understanding of what a planet can be. Some are rocky, others gaseous, and still others exist in states altogether unfamiliar to us. There are super-Earths with masses greater than our own planet, and hot Jupiters, gas giants that orbit so close to their stars that their atmospheres are blasted by intense starlight. The diversity of these worlds challenges our definitions and beckons us to reconsider the very nature of planetary formation. In this exploration, we are reminded of the universality of the laws that govern the cosmos. The same forces that sculpted our solar system are at work in these distant systems, guided by the same principles of physics and chemistry. The interplay of gravity, heat, and time creates an endless variety of planetary forms, each one a testament to the creativity of the universe. And within this cosmic dance, we find not only questions about the nature of these distant worlds, but also reflections on our own place in the grand scheme of things. The study of planets, whether near or far, prompts us to consider the potential for life beyond Earth. In the delicate balance of conditions required for life as we know it, we seek the presence of liquid water, an atmosphere, and a stable environment. These criteria guide our search, yet they also invite us to imagine the possibilities of life in forms we have yet to conceive. Could life exist in the clouds of a gas giant, or beneath the icy crust of a distant moon? The questions are as boundless as the universe itself, each one a thread in the rich tapestry of cosmic inquiry. As we journey through this vast expanse, we find ourselves not just observers of distant worlds, but participants in a shared cosmic narrative. The elements that form planets and stars are the same elements that make up our own bodies, forged in the hearts of ancient stars and scattered across the universe by supernovae. In this way, we are intimately connected to the cosmos, our existence intertwined with the life cycles of stars and the evolution of galaxies. In contemplating this interconnectedness, we are invited to reflect on the nature of time itself. The formation of a planet is a process that unfolds over millions of years, a gradual accretion of material that eventually gives rise to a world. This slow, deliberate pace contrasts sharply with the fleeting span of human life, yet it offers a perspective that is both humbling and profound. The planets, in their enduring presence, remind us of the continuity of creation and the resilience of nature. As we continue to explore the universe, we carry with us the tools of science, a means of understanding the world that is rooted in observation, experimentation, and reason. Through the lens of science, we unravel the mysteries of the cosmos, each discovery adding to our collective knowledge and deepening our appreciation of the natural world. Yet alongside this scientific inquiry, we also embrace a sense of wonder and curiosity, an openness to the unknown that fuels our imagination and inspires our dreams. In this spirit of exploration, we find a balance between knowledge and mystery, between understanding and awe. The universe, in all its vastness, is a source of endless fascination, a reminder of the beauty and complexity that lie beyond our everyday experience. As we gaze into the night sky, we are drawn not only to the stars and planets that twinkle in the distance, but also to the questions they inspire within us. Whether we are gazing at the craters of the moon, the swirling clouds of Jupiter, or the distant light of a far-off exoplanet, we find ourselves part of a larger story, a cosmic journey that stretches back to the dawn of time and extends into the future. This journey, with its challenges and discoveries, its moments of clarity and wonder, invites us to explore, to learn, and to dream. As we ponder the diversity of worlds and the forces that shape them, we are reminded of the delicate balance that sustains life on our own planet. The Earth, with its vibrant ecosystems and complex web of life, is a rare and precious home, a testament to the resilience and adaptability of life in the face of a constantly changing environment. In studying other planets, we gain insights into our own, learning not only about the processes that govern their formation, but also about the conditions that make life possible. In this way, the exploration of space becomes a journey of self-discovery, a quest to understand not only the universe but also our place within it. The planets and stars, in their silent majesty, offer us a mirror in which to see ourselves, a reminder of the interconnectedness of all things and the shared destiny of life in the cosmos. As we continue to look outward, our gaze is inevitably drawn back to Earth, to the blue and green orb that is our home. Here, amidst the vastness of space, we find a sanctuary, a place where life has taken root and flourished. It is a world of beauty and diversity, a fragile oasis in the cosmic ocean. And as we contemplate the planets beyond, we are reminded of the responsibility we bear to protect this planet, to cherish its wonders and safeguard its future. In this moment of reflection, we find both inspiration and purpose, a sense of connection to the universe and to one another. The exploration of space is not just a scientific endeavor, but a journey of the human spirit, a testament to our curiosity and our desire to understand the world around us. It is a journey that continues to unfold, inviting us to explore the mysteries of the cosmos and to embrace the beauty of the universe in all its forms. As we conclude our contemplation of the planets and the forces that shape them, we find ourselves drawn to the possibilities that lie ahead. The universe, in its infinite complexity, holds secrets yet to be discovered, worlds yet to be explored. And as we venture forth into this vast expanse, we do so with a sense of wonder and gratitude, a recognition of the beauty and mystery that surround us. In this journey, we are not alone. We are part of a greater whole, a tapestry of life and matter that extends across the cosmos, connecting us to the stars and to each other. The celestial dance of planets, stars, and galaxies unfolds in a cosmic symphony, an orchestration of forces that have shaped the universe over billions of years. Within this grand composition, The story of rocky and gaseous planets provides a fascinating glimpse into the processes that govern the formation and evolution of planetary systems. As we ponder these distant worlds, our thoughts drift to the ways in which these planets are not just isolated entities, but integral components of a larger cosmic mechanism, each one a unique expression of the conditions that prevailed in its formative years. In the swirling disk of gas and dust that surrounded the nascent sun, countless particles collided and coalesced, driven by the inexorable pull of gravity. Rocky planets, like the familiar members of our inner solar system, emerged from this primordial chaos, their solid bodies forged from the heavy elements that had been synthesized in the cores of ancient stars. These elements, scattered across the universe by supernovae, found a new home in the forming planets, where they became the bedrock of landscapes, the minerals in soils, and the metals that conduct electricity. The very ground beneath our feet is a testament to the cosmic cycles that recycle and renew the building blocks of matter, weaving them into new forms over the eons. Beyond the rocky worlds, in the colder reaches of the solar system, the gas giants took shape. Here, the abundance of lighter elements such as hydrogen and helium allowed these planets to grow massive, enveloping themselves in thick atmospheres that conceal their core compositions. The gas giants, with their swirling storms and intricate cloud patterns, present a spectacle of dynamic weather systems and atmospheric phenomena. The interplay of factors such as temperature, pressure, and chemical composition creates environments that, while inhospitable to life as we know it, are nonetheless captivating in their complexity. The exploration of gas giants has revealed the presence of intricate ring systems, composed of countless particles of ice and rock, each one tracing an orbit that is a dance of celestial mechanics. These rings, so delicate and ephemeral from a distance, are the remnants of past collisions, or the remnants of moons torn apart by gravitational forces. They remind us that even the most seemingly permanent structures in our universe are subject to change, carried along by the currents of time and transformation. As we consider the variety of planetary forms, our gaze naturally extends beyond our solar system to the realms of exoplanets, worlds that orbit stars other than our sun. With the advancement of technology, we have become adept at detecting these distant planets, each discovery adding to the tapestry of planetary diversity. Some exoplanets, known as super-Earths, are more massive than our home planet yet remain rocky in nature, challenging our understanding of how size and composition are interrelated. Others, like the mysterious hot Jupiters, orbit perilously close to their stars, their atmospheres seared by intense radiation, revealing the breadth of planetary configurations that can arise. In this vast expanse, the possibility of life on other worlds continues to tantalize our imaginations. The search for life beyond Earth is guided by the principle of habitability, which considers factors such as the presence of liquid water, a suitable atmosphere, and the right chemical ingredients. Yet, as we expand our search, we are reminded that life may exist in forms and environments that we have yet to conceive. The thought of life thriving in the upper atmospheres of gas giants, or beneath the icy crusts of distant moons, invites us to broaden our definitions and to remain open to the surprises that the universe may hold. The study of planets, whether they are close at hand or light years away, is a journey that connects us to the fundamental processes that shape the cosmos. It reminds us that the forces that sculpt worlds are the same forces that govern the stars and galaxies, a testament to the universality of the laws of physics. These laws, while seemingly immutable, are the keys to unlocking the mysteries of the universe, guiding us as we seek to understand the origins of planets and the potential for life beyond our own. In contemplating these distant worlds, it becomes clear that our quest for knowledge is not merely an intellectual pursuit, but a deeply human endeavor, one that reflects our innate curiosity and our desire to understand our place in the universe. The exploration of space challenges us to look beyond the confines of our immediate surroundings, to consider the broader implications of our actions, and to recognize the interconnectedness of all things. As we send probes and telescopes into space, we are reminded of the ingenuity and perseverance that have marked humanity's journey from the earliest stargazers to the scientists and explorers of today. Each mission, each discovery, is a step forward in our collective quest to understand the universe and our role within it. The knowledge gained from studying planets, both near and far, enriches our understanding of Earth's own history, its climate, and its potential futures. The responsibility that comes with this knowledge is profound. As stewards of our planet, we are tasked with ensuring its health and stability for future generations. The lessons learned from other planets about atmospheric dynamics, geological processes, and the delicate balance of ecosystems can inform our efforts to protect and preserve Earth. In doing so, we honor the legacy of those who have come before us and pave the way for those who will follow. In this shared journey, the cosmos becomes not just a backdrop to our lives, but a source of inspiration and reflection. The planets, in their diversity and beauty, invite us to marvel at the creativity of nature and to appreciate the intricate patterns that connect us all. They remind us that while we may be small in the grand scheme of things, we are part of something much larger, a cosmic community bound together by the threads of time and space. As we continue to explore the universe, let us do so with a sense of wonder and humility, mindful of the vastness of the unknown and the potential for discovery. The stars beckon us to look upward and outward, to seek answers to the questions that have captivated humanity for millennia. In this pursuit, we are united in our curiosity, our dreams, and our hopes for the future. The universe, in its infinite complexity and beauty, is a reminder of the boundless possibilities that await us. Each new discovery is a testament to the power of human imagination and the enduring spirit of exploration. As we forge ahead, let us carry with us the knowledge that we are not alone in this journey, that we are part of a greater whole, and that the universe, in all its wonder, is ours to explore, to understand, and to cherish. In the vast expanse of the universe, where countless stars twinkle against an infinite backdrop, each celestial body narrates its own story of creation and existence. Among these are the planets, formed by the dust and gas left over from the birth of stars. These planets, each unique, arise from a dance of gravity and time, sculpted by the forces of nature into diverse worlds. As we continue to unravel the mysteries of why some planets are rocky and others gaseous, we delve deeper into the processes that govern planetary formation and the factors that make each planet distinct. At the heart of this story lies the protoplanetary disk, a swirling mass of gas and dust that surrounds a newborn star. Within this disk, countless particles collide and coalesce, gradually forming larger bodies known as planetesimals. Over millions of years, these planetesimals merge to form planets. The fate of these nascent worlds depends greatly on their distance from the star. Closer to the star, where temperatures are higher, volatile compounds like water and methane cannot condense. This region gives birth to rocky planets, rich in metals and silicates, as these materials can withstand the heat and remain solid. Here, in this zone, the terrestrial planets such as Earth, Mars, Venus, and Mercury take shape. Their solid surfaces and relatively dense compositions are a testament to the fiery crucible from which they emerged. Further from the star, beyond what is known as the frost line, temperatures drop significantly, allowing icy compounds to solidify. This cooler environment is conducive to the formation of gas giants. In these outer regions, planetesimals can accumulate not just rock and metal but also ices, which provide a substantial increase in mass. As these icy cores grow, they attract a vast envelope of gas, primarily hydrogen and helium, the most abundant elements in the universe. This accretion of gas is what defines the gaseous giants such as Jupiter and Saturn. Their immense size and mass enable them to hold onto their thick atmospheres, which swirl with complex weather patterns and contribute to their majestic, banded appearances. The story of planetary formation is also one of migration. Planets do not always remain in the orbits where they initially formed. Through interactions with the protoplanetary disk and other celestial bodies, they can migrate to new positions within their solar systems. This phenomenon is particularly evident in exoplanetary systems, where we observe gas giants orbiting very close to their stars, in regions where we would typically expect to find rocky planets. These so-called hot Jupiters challenge our understanding of planetary dynamics and hint at the turbulent history of their systems. The distinction between rocky and gaseous planets also invites contemplation of the environments they offer. Rocky planets, with their solid surfaces, provide the possibility of stable ground where life, as we understand it, might gain a foothold. The presence of water, a critical ingredient for life, is more likely on these worlds, whether in the form of surface oceans or hidden beneath layers of ice. Earth, our home, exemplifies the potential of a rocky planet to host life, with its diverse ecosystems and complex biosphere. On the other hand, the gas giants, with their thick atmospheres and lack of solid surfaces, present a different kind of challenge for life. Their atmospheres, composed mostly of hydrogen and helium, are inhospitable by earthly standards. Yet, the possibility of life, or at least some form of it, cannot be entirely ruled out. Some scientists speculate about the potential for life in the upper atmospheres of gas giants, where temperatures and pressures might be more conducive to biological processes. Moreover, the moons of these giants, such as Europa and Titan, capture our imagination with their icy surfaces and subsurface oceans, expanding our notion of habitable environments. As we peer into the cosmos, the diversity of planets reminds us of the myriad ways in which planetary systems can evolve. The discovery of super-Earths and mini-Neptunes, planets that do not exist in our solar system, further enriches our understanding. These worlds, with sizes and compositions between that of Earth and Neptune, open new possibilities for exploration and study. They challenge our categorizations and encourage us to refine our models of planet formation and evolution. In contemplating these distant worlds, we also reflect on our place in the universe. The study of planets beyond our own solar system, a field that has grown exponentially in recent decades, connects us to the broader cosmos. The search for exoplanets, especially those that might harbor life, is driven by a profound sense of curiosity and wonder. Each new discovery is a reminder of the vastness of space and the potential for countless other worlds, each with its own story, its own possibilities. The journey of understanding why some planets are rocky and others gaseous is not only a scientific endeavor but also a philosophical one. It speaks to our innate desire to comprehend the universe and our place within it. As we continue to explore, we carry with us the hope that one day we might find answers to some of our most profound questions. Are we alone? What is the nature of life beyond Earth? How did we come to be in this vast universe? As you consider these questions, let the gentle pull of curiosity guide you. The universe, in its grand tapestry, weaves together threads of mystery and discovery. With each step forward, we learn more about the cosmic forces that shape our existence. We are part of a continuum, a journey that stretches back to the dawn of time and extends into a future of limitless possibilities. As we navigate this path, let us do so with humility and an open heart, for the universe is vast and its wonders are boundless. In this shared journey of exploration, we are reminded of the interconnectedness of all things. The same elements that form the stars and planets also constitute our own bodies. We are made of stardust, born from the remnants of ancient stars that lived and died long before our own sun came into existence. This cosmic heritage binds us to the universe and to each other, a reminder that we are all part of the same great story. As we look to the skies, let us marvel at the beauty and complexity of the cosmos. Let us cherish the knowledge that we are explorers, ever curious, ever seeking to understand more. The universe, in its infinite expanse, invites us to wonder, to dream, and to imagine. Each discovery, each new insight brings us closer to understanding the grand tapestry of existence. While we may not have all the answers, the pursuit of knowledge is a journey worth undertaking. It is a journey that enriches our lives and deepens our connection to the world around us. In the quiet moments of reflection, let us find peace in the knowledge that we are part of something greater, a vast cosmos filled with endless wonder. As we continue to explore, let us do so with a spirit of curiosity and a commitment to stewardship. For the universe is not just a place we observe, but a part of which we are an integral piece. In the end, the story of rocky and gaseous planets is a story about us, about our quest for understanding and our place in the universe. It is a story that reminds us of the beauty and complexity of existence and the endless possibilities that lie ahead. As we journey forward, may we carry with us the sense of wonder and awe that the universe inspires, and the knowledge that, in seeking to understand it, we are also seeking to understand ourselves. The study of planets, both rocky and gaseous, opens a window into the complex mechanics of the universe, revealing not only the diversity of planetary forms, but also the intricate interactions that govern their existence. As we look deeper into the cosmos, we are reminded of the delicate balance maintained in the celestial dance, where gravity and motion coalesce to shape the destiny of these celestial bodies. The planets, in their varied forms and compositions, tell stories of creation, destruction, and rebirth, echoing the cycles that permeate the universe. In considering the characteristics that differentiate rocky planets from their gaseous counterparts, we must look beyond mere physical composition to the environments that foster their development. The interplay of temperature, pressure, and material availability in the protoplanetary disk dictates the eventual form a planet will take. Closer to the star, where heat reigns supreme, heavier elements like iron and silicon coalesce to form dense, rocky worlds. These terrestrial planets are marked by their solid surfaces and relatively thin atmospheres, often the result of volcanic outgassing or the capture of primordial gases. Yet, despite these commonalities, each rocky planet is a unique entity, shaped by its own history of impacts, tectonics, and erosion. Beyond the frost line, where the chill of space allows volatile compounds to freeze, gaseous planets emerge, their massive envelopes of hydrogen and helium gathered from the primordial nebula. These gas giants, with their swirling atmospheres and intricate weather systems, stand as titans of the solar system, their gravity influencing the orbits of moons, rings, and even other planets. The formation of these giants is not merely a process of accumulation, but a story of migration and interaction, where gravitational forces and disk dynamics play crucial roles in their eventual settling. The wonder of planetary science lies in the realization that these processes are universal. The discovery of exoplanets, planets orbiting stars beyond our Sun, has expanded our understanding of planetary formation, offering glimpses into the myriad ways in which planets can manifest. Among these discoveries are worlds that challenge our preconceived notions, such as super-Earths and mini-Neptunes, which occupy a size range between Earth and Neptune, yet do not fit neatly into the categories of rocky or gaseous. These planets, with their diverse compositions and atmospheres, invite us to reconsider the boundaries of planetary classification, urging us to refine our theories to accommodate the breadth of planetary diversity observed. The study of exoplanets also brings to light the phenomenon of planetary migration, where planets do not remain fixed in their birthplaces, but instead drift through their star systems. This movement can result in gas giants situated close to their stars, known as hot Jupiters, which defy the expectations set by our own solar system. These planets, with their scorching temperatures and close orbits, test our models of planetary dynamics and hint at the complex interactions that occur between planets and their natal disks. In exploring the atmospheres of these distant worlds, we gain insights into their compositions and climates, revealing not only their potential for hosting life, but also the processes that drive atmospheric evolution. The presence of clouds, storms, and even potential signs of chemical processes akin to those on Earth beckons us to look closer, to peer into the atmospheres of these alien worlds and seek the threads that connect them to our own. The quest to understand planets, both near and far, reflects our innate desire to comprehend our surroundings and our place within them. It is a pursuit that mirrors our own evolution, as we strive to unravel the mysteries of our origins and the forces that have shaped our world. In studying the planets, we engage in a dialogue with the universe, one that spans time and space, linking past, present, and future. As we continue to explore, the technological advancements we employ not only expand our reach, but also refine our perspective. Telescopes, both terrestrial and space-based, extend our vision beyond the visible spectrum, allowing us to detect the faint signatures of distant worlds and the subtle shifts in starlight that signal their presence. These instruments, born of human ingenuity, serve as extensions of our senses, enabling us to perceive the universe in ways that transcend our limitations. In the pursuit of knowledge, we also recognize the importance of collaboration and the sharing of discoveries. The field of planetary science is inherently interdisciplinary, drawing upon the expertise of astronomers, geologists, chemists, and physicists, each contributing to a fuller understanding of the cosmos. This collective effort embodies the spirit of exploration, where the union of diverse perspectives enriches our comprehension and propels us forward. The planets, in all their variety and splendor, serve as reminders of the vastness of the universe and the intricate tapestry of forces that weave through it. They stand as milestones in our journey of discovery, each one a testament to the power of science to illuminate the unknown. As we ponder the planets, we are drawn into a deeper reflection on the nature of existence, the fragility of life, and the interconnectedness of all things. In this exploration, we find not only knowledge but also inspiration, a call to cherish the planet we call home and to preserve its beauty for future generations. For in studying the planets, we are reminded of the preciousness of our own world and the responsibility we bear as its stewards. The insights gained from distant worlds serve to highlight the delicate balance that sustains life on Earth, urging us to act with foresight and care. As we gaze upon the night sky, filled with countless stars, we are humbled by the realization of our place within the cosmos. Each planet we discover, each mystery we unravel, brings us closer to understanding the universe and our unique position within it. The journey of exploration is one without end, a continuous unfolding of the wonders that lie beyond our horizon. In this vast expanse, the planets remain beacons of curiosity, guiding us as we navigate the unknown. They inspire us to dream, to question, and to seek answers to the profound questions that have long captured the human spirit. In this endeavor, we find not only the joy of discovery, but also a deeper connection to the universe and to each other. May our exploration of the planets continue to ignite our imagination, fostering a sense of unity and purpose as we reach for the stars. In the silent, unending dance of the cosmos, we are both observers and participants, each new discovery a step further into the mystery and majesty that is the universe. In the tapestry of the universe, the intricate dance between rocky and gaseous planets unfolds with a quiet elegance that invites contemplation. As we ponder the diversity of planetary bodies, we are reminded of the delicate balance of forces that shape their formation. The Sun, a luminous anchor in our solar system, plays a critical role in this cosmic ballet. Its gravitational pull and radiant energy influence the composition and structure of planets, dictating their fate from the moment of their birth in the swirling disk of dust and gas. In the inner reaches of this disk, where temperatures soar, the rocky planets emerge, their cores solidified by the heat and pressure of their proximity to the star. These terrestrial worlds, with their dense, metal-rich compositions, tell tales of fiery beginnings and relentless bombardment, their surfaces scarred by the passage of time. Beyond the asteroid belt, where the sun's warmth wanes, the gaseous giants take form. Here, in the realm of the frost line, the temperature drops to a point where volatile compounds like water, ammonia, and methane can condense into solid ice. This process allows for the accumulation of vast amounts of material, forming the massive, swirling atmospheres of planets such as Jupiter and Saturn. Their sheer size and the abundance of lighter elements like hydrogen and helium give rise to their expansive, cloud-laden appearances. These worlds, with their majestic rings and myriad moons, offer a glimpse into the dynamic processes that govern planetary evolution. The gas giants serve as guardians of the outer solar system, their immense gravity shaping the orbits of countless smaller bodies, shielding the inner planets from potential impacts. In the vast expanses beyond Neptune, the icy realms of the Kuiper Belt and the Oort cloud hold further mysteries. Here, the leftovers of planetary formation linger, remnants from a time when the solar system was a bustling nursery of celestial objects. These distant regions, where sunlight barely reaches, are home to countless icy bodies, some of which occasionally venture into the inner solar system as comets. These cosmic wanderers, with their luminous tails and ancient origins, carry with them clues to the early conditions of our solar system. As they approach the sun, their icy surfaces sublimate, releasing gases and dust that form a glowing coma, a spectacle of ephemeral beauty that has fascinated observers for centuries. The story of why some planets are rocky and others gaseous is not just a tale of distance and temperature. It is also a narrative of composition and elemental abundance. The primordial cloud from which our solar system emerged was rich in hydrogen and helium, the simplest and most abundant elements in the universe. Yet, it also contained trace amounts of heavier elements, forged in the hearts of ancient stars and scattered across the cosmos by cataclysmic supernovae. These elements, the building blocks of planets, accreted over time, influenced by the gravitational forces and energy dynamics of the young sun. To understand the diversity of planetary types, one must also consider the concept of planetary migration. In the early solar system, gravitational interactions between planets and the surrounding disk of gas and dust could cause planets to shift their orbits over time. This process, known as migration, can lead to scenarios where gas giants form far from their stars but eventually move inward, altering the layout of the planetary system. Such migrations can have profound effects, potentially disrupting the formation of terrestrial planets or influencing their final compositions. The discovery of exoplanets, worlds orbiting stars beyond our sun, has provided further insights into these processes. Many exoplanetary systems feature gas giants located close to their stars, a configuration that challenges our understanding and prompts new theories about planetary dynamics and evolution. The study of exoplanets has expanded our perspective, revealing a staggering diversity of worlds, each with its own unique characteristics. Some are rocky, like Earth, while others are enveloped in thick atmospheres of hydrogen and helium, resembling the gas giants of our solar system. There are also super-Earths, planets with masses greater than Earth's but smaller than Neptune's and mini-Neptunes, which hint at the rich tapestry of planetary possibilities. The search for Earth-like worlds in the habitable zones of their stars, regions where liquid water could potentially exist, continues to captivate scientists and enthusiasts alike, driving the quest to understand the conditions necessary for life. The tools we use to explore these distant worlds are as varied as the planets themselves. Telescopes, both on Earth and in space, peer into the cosmos, capturing light from stars and the planets that orbit them. Advanced spectroscopic techniques allow scientists to analyze the composition of planetary atmospheres, searching for chemical signatures that could hint at geological activity or even biological processes. Spacecraft, like the Voyager and New Horizons missions, have ventured into the far reaches of our solar system, sending back images and data that enrich our understanding of the worlds that share our celestial neighborhood. In the grand scheme of the universe, the formation of rocky and gaseous planets is a testament to the intricate interplay of physics and chemistry, a process governed by the same fundamental laws that shape galaxies and stars. Yet, despite the vastness of the cosmos, these processes are also intimately connected to our own existence. The atoms that make up our bodies were once part of ancient stars, and the processes that formed the planets also laid the groundwork for the emergence of life. In studying the planets, we are not just seeking to understand their origins and characteristics. We are also exploring the conditions that make life possible, and perhaps discovering our own place in the universe. As we continue to explore and learn, let us marvel at the complexity and beauty of the cosmos. The story of rocky and gaseous planets is but one chapter in the epic tale of the universe, a narrative that spans billions of years and countless stars. Each discovery, each new insight, adds to our collective knowledge, enriching our understanding of the universe and our connection to it. In this pursuit, we are united by a shared curiosity and a desire to uncover the mysteries that lie beyond our world. In the quiet moments of reflection, as we gaze upon the night sky, let us remember the wonder that inspired our journey of exploration. The stars, distant and eternal, have guided travelers for millennia, their light a beacon of hope and discovery. In their glow, we find a reminder of our own potential, a call to continue our quest for knowledge and understanding. The universe, vast and mysterious, holds untold secrets, waiting to be discovered by those who dare to look beyond the horizon. As we ponder the nature of planets, both rocky and gaseous, let us also embrace the journey itself, a journey that is as much about the questions we ask as the answers we find. May this exploration inspire us to cherish our own planet, a fragile oasis in the vast cosmic ocean. Earth, with its vibrant ecosystems and rich diversity of life, is a testament to the delicate balance of conditions that allow life to flourish. In our quest to understand the planets, may we also be reminded of the importance of preserving and protecting our own world, ensuring that future generations can continue to marvel at the wonders of the universe. The story of rocky and gaseous planets is a reminder of the interconnectedness of all things, a reflection of the cosmic forces that bind us to the stars. In this grand tapestry, we find not only the answers to the questions that have long captured our imagination, but also a deeper appreciation for the beauty and complexity of existence. Let us continue to explore, to question, and to seek understanding, guided by the light of the stars and the wonder of the universe. As we reach for the stars, may we find in them a reflection of our own journey, a journey that is as timeless as the cosmos itself. In this vast expanse of space, where the light of distant stars whispers secrets of ages past, the story of planet formation unfolds in myriad ways, each path shaped by the delicate balance of forces and materials. As we consider the diversity among planets, both within our solar system and beyond, we delve deeper into the subtle mechanics that govern their creation. The dichotomy between rocky and gaseous planets is, at its essence, a dance of chemistry and physics, a complex interplay of temperature, pressure, and the primordial building blocks available in the protoplanetary disk. In the inner realms of a solar nebula, where the nascent sun's embrace is warmest, Rocky planets like our own Earth take shape from silicates and metals. Here, closer to the embryonic star, temperatures are high enough to drive away volatile compounds such as water, ammonia, and methane, leaving behind the heavier elements that coalesce into solid bodies. These terrestrial planets are born amidst the heat and turbulence, their surfaces sculpted by volcanic activity, tectonic forces, and the relentless impact of asteroids and comets. Venturing into the cooler regions beyond the asteroid belt, we encounter the grandiose gas giants, behemoths of hydrogen and helium, cloaked in swirling clouds. It is in these more distant orbits that the conditions allow for the accumulation of lighter gases, forming thick atmospheres around solid cores. Jupiter and Saturn, with their expansive atmospheres and complex weather systems, serve as reminders of the dynamic processes at work in the outer solar system. Yet each of these giants tells a unique story. The intricate bands of clouds that encircle Jupiter, for instance, are not merely aesthetic wonders, but the visible manifestations of underlying atmospheric currents, driven by the planet's rapid rotation and internal heat. Similarly, Saturn's rings, composed of countless icy particles, reveal a history of gravitational interactions and collisions, a testament to the ever-changing nature of these distant worlds. Planets like Uranus and Neptune, further still from the Sun, present their own mysteries. Often referred to as ice giants, their composition diverges from that of their larger siblings, with higher proportions of water, ammonia, and methane. These elements, frozen in the icy depths of these planets, give rise to unique atmospheric phenomena and magnetic fields that intrigue and puzzle scientists. The axial tilt of Uranus, nearly lying on its side compared to the other planets, hints at a past collision that drastically altered its orientation, a reminder of the chaotic early days of the solar system. In contemplating the makeup of these planetary giants, we are drawn to the idea of planetary migration, a process that suggests these worlds may not have formed where we find them today. The gravitational interplay between planets can lead to dramatic shifts in their orbits, a cosmic ballet that reshapes entire solar systems. Such migrations may help explain why some exoplanets, orbiting other stars, defy our expectations, existing in configurations unlike any we see in our solar system. These findings challenge us to expand our models of planet formation and evolution, embracing the diversity of planetary systems as a natural consequence of their chaotic beginnings. Our understanding of planetary atmospheres is deepened by the study of exoplanets, where the interplay of light and matter reveals the chemical fingerprints of distant worlds. By observing the subtle dimming of starlight as a planet transits its host star, astronomers can infer the composition and structure of its atmosphere. This technique, known as spectroscopy, has unveiled a rich tapestry of atmospheric constituents, from clouds of silicate dust to skies painted with the blues and reds of alien sunsets. Each discovery adds a brushstroke to our portrait of the cosmos, inviting us to imagine the myriad climates and environments that exist beyond our solar neighborhood. As we peer through the lenses of our telescopes, we are reminded of the vastness of the universe and the myriad ways in which planets can form and evolve. The search for Earth-like worlds, with conditions suitable for life as we know it, continues to drive our exploration, but it is the unexpected discoveries that often hold the most profound implications. These findings not only challenge our understanding of planet formation, but also expand the boundaries of what we consider possible in the universe. In the quiet moments of reflection, we consider the implications of these cosmic journeys. The knowledge we gain from studying other worlds informs our understanding of our own planet, offering insights into climate, geology, and the fragile balance of ecosystems. The story of planetary formation is not just a tale of distant worlds, but a reminder of the interconnectedness of all things, a reflection of the universal principles that govern the cosmos. As we continue to explore, we are guided by the same curiosity that has driven humanity for millennia. The drive to understand our place in the universe, to seek out the unknown, is an intrinsic part of our nature. In the silent expanse of space, we find echoes of our own journey, a testament to the enduring quest for knowledge and the profound beauty of the universe. In this grand exploration, the tools we use, from the delicate instruments aboard space probes to the powerful eyes of ground-based observatories, serve as extensions of our senses, allowing us to reach across the void and touch the stars. These instruments, products of human ingenuity and collaboration, are our companions in the quest for understanding, opening windows to worlds yet unseen and stories yet untold. As we continue to unravel the mysteries of the cosmos, we must also consider the legacy we leave for future explorers. The knowledge we gather is a gift to the generations that will follow, a foundation upon which they will build their own understanding of the universe. It is a reminder of the responsibility we bear to preserve the wonders of our own planet, ensuring that it remains a beacon of life in the vastness of space. In the gentle light of distant stars, we find a sense of perspective, a reminder of our place in the grand tapestry of existence. The story of planetary formation is but one chapter in the cosmic narrative, a story that continues to unfold with each new discovery. As we gaze upward, let us carry with us the spirit of inquiry and wonder, embracing the unknown with open hearts and open minds. And so, as we reflect on the wonders of the universe, we are reminded of the beauty and complexity of the cosmos, a reflection of our own journey and the timeless quest for understanding. In the quiet moments, let us contemplate the stars and the stories they tell, finding inspiration in their light and solace in their constancy. As we reach out into the universe, may we always carry with us the spirit of exploration and the promise of discovery, guided by the stars and the endless possibilities they represent. And so we find ourselves gazing into the vast expanse, where the light of distant stars reaches us across unimaginable distances, whispering tales of their origins and destinies. Each star, a fiery sphere of hydrogen and helium, is a testament to the forces of gravity and nuclear fusion, birthing energy and light in a delicate balance. From their incandescent cores, stars emit energy that travels across the cosmos, nurturing planets and shaping the very fabric of galaxies. These stars, in their life cycle, play an integral role in the creation of the elements, serving as the factories of the universe. Through the process of stellar nucleosynthesis, they forge the heavier elements in their cores, elements that are the building blocks of planets and, indeed, life itself. When massive stars reach the end of their life cycles, they explode in spectacular supernovae, scattering these enriched materials across the cosmos. As these remnants of stars drift through the galaxy, they become part of interstellar clouds, vast regions of gas and dust. Here, the cycle of star formation begins anew. Within these clouds, dense regions collapse under the force of gravity, giving birth to new stars. Surrounding these nascent stars are protoplanetary disks, swirling masses of gas and dust, where planets begin to form. It is within these disks that the intricate dance of cosmic forces unfolds, leading to the diverse array of planetary systems we observe. As you ponder this cosmic dance, consider the remarkable journey of a single atom, perhaps carbon or oxygen, as it travels from the heart of a star to the soil of a distant world. This journey, spanning eons, connects us to the very stars themselves and to the universe at large. The exploration of exoplanets, planets that orbit stars beyond our own sun, has opened a new chapter in our understanding of planetary formation and diversity. Using sophisticated techniques such as the transit method and radial velocity measurements, astronomers have discovered thousands of exoplanets, each with its unique characteristics. These distant worlds challenge our notions of planetary systems, revealing configurations and compositions that were once thought improbable. Some exoplanets orbit their stars in mere days, while others take centuries to complete a single orbit. There are planets with surfaces of scorching lava, worlds with skies filled with silicate clouds, and even planets where it rains molten glass sideways due to ferocious winds. The diversity is staggering, and it beckons us to reconsider the possibilities of what planets can be. In this quest to understand exoplanets, astronomers also seek to answer one of the most profound questions: the potential for life beyond Earth. By studying the atmospheres of these distant worlds, scientists search for biomarkers, signatures of life that might be detected from afar. The presence of certain gases, such as oxygen or methane in specific ratios, could hint at biological processes similar to those on Earth. With missions like the James Webb Space Telescope, capable of peering into the atmospheres of these distant worlds, we are on the brink of potentially transformative discoveries. The search for life is not merely a pursuit of extraterrestrial curiosity, but also a journey to understand the conditions that foster life as we know it. The cosmic environment in which planets and stars exist is not static. It is a dynamic tapestry continuously shaped by interactions between celestial bodies. Gravitational forces sculpt galaxies into spirals and ellipticals, while dark matter, an enigmatic substance that does not emit light, yet exerts gravitational influence, holds galaxies together. The interplay of these forces determines the large-scale structure of the universe, a cosmic web of filaments and voids. On a smaller scale, the gravitational interactions within star systems can lead to dramatic events, such as the capture or ejection of planets, the formation of binary stars, or the collision of galaxies. When galaxies collide, they merge their stars, gas, and dust, triggering bursts of star formation and sometimes igniting the central supermassive black holes that lie in the hearts of most galaxies. Black holes themselves are another intriguing aspect of the universe. These regions of spacetime exhibit such strong gravitational effects that nothing, not even light, can escape from within them. The concept of a black hole challenges our understanding of physics and the nature of reality itself. Yet, they are not merely cosmic curiosities. They play a vital role in the evolution of galaxies. As matter falls into a black hole, it heats up and emits powerful jets of radiation, influencing the surrounding environment. These jets can regulate star formation within a galaxy, demonstrating the interconnectedness of cosmic phenomena. As you consider these vast cosmic processes, ponder the role that human observation and ingenuity have played in unveiling these mysteries. From ancient astronomers who charted the movement of stars across the night sky, to modern scientists who probe the depths of space with advanced telescopes, our quest for knowledge has been unrelenting. Each discovery builds upon the last, a testament to the cumulative nature of scientific inquiry. The development of powerful telescopes and observatories, both on Earth and in space, has expanded our ability to observe the universe in unprecedented detail. These tools allow us to look back in time, observing light that has traveled billions of years to reach us, providing a window into the early universe and the formation of the first galaxies and stars. In this grand narrative, the Earth holds a special place. It is here, on this pale blue dot, that life has flourished in all its diversity. The conditions that have allowed life to thrive are the result of a delicate balance of factors, from the planet's distance from the Sun to the composition of its atmosphere and the presence of water. Earth's biosphere is a testament to the complexity and resilience of life. As stewards of this planet, we hold the responsibility to understand and preserve the intricate systems that sustain us. The knowledge gained from studying other planets and the universe at large enriches our appreciation of Earth and underscores the importance of protecting our home. The future of space exploration holds the promise of new horizons and discoveries. With the advancement of technology and international collaboration, missions to the Moon, Mars, and beyond are being planned, each step taking us further into the solar system. These endeavors are not merely about reaching new destinations, but about expanding our understanding of the universe and our place within it. They inspire generations to look upward and dream of what lies beyond, fostering a spirit of exploration and curiosity that transcends borders and unites humanity in a shared quest for knowledge. In contemplating the universe, we are reminded of both our insignificance and our potential. The vastness of space humbles us, yet the ability to comprehend and explore it speaks to the remarkable capabilities of the human mind. As we continue on this journey, may we remain guided by the principles of inquiry, collaboration, and stewardship, ever mindful of the interconnectedness of all things. Let us cherish the stories written in the stars, for they are a reflection of our collective journey, a testament to the enduring spirit of discovery that defines us as a species. And as we journey through the cosmos, may we always find solace in the constancy of the stars, ever present, ever guiding, illuminating the path forward in our quest to understand the universe and our place within it. In the vast expanse of the cosmos, the dance of celestial bodies unfolds in myriad forms, each telling its own story of origin and evolution. Among the most intriguing of these are the planets themselves, each a distinct world with its own character and composition. As we ponder the diversity of these planetary bodies, we find ourselves drawn to the fundamental question of why some planets are rocky and others gaseous. It is a question that invites us to consider the delicate balance of cosmic forces and the intricate processes that govern planetary formation. At the heart of this inquiry lies the protoplanetary disk, a swirling region of dust and gas that surrounds a young star. Within this nebula, the seeds of planets are sown, beginning their journey as small particles that gradually coalesce through the process of accretion. Over time, these particles form planetesimals, the building blocks of planets. The materials present in the disk, influenced by the star's heat and radiation, play a crucial role in determining the eventual nature of the planets. Closer to the star, where temperatures soar, only materials with high melting points can withstand the intense heat. These include silicates and metals, which coalesce to form the rocky planets. These terrestrial worlds, like our own Earth, are characterized by solid surfaces and dense compositions. Their proximity to the star ensures that volatile compounds, such as water and carbon dioxide, are largely driven away, either evaporating or being incorporated into the planet's interior. As we move farther from the star, the temperatures drop significantly, allowing lighter and more volatile compounds to condense. In these colder regions, ices and gases can accumulate, giving rise to the gas giants. These planets, such as Jupiter and Saturn, are composed primarily of hydrogen and helium, with small rocky cores hidden beneath thick, swirling layers of gas. The vast amounts of material available in these outer regions enable these planets to grow to immense sizes, capturing and retaining their gaseous envelopes. The boundary between these two types of planets is not a sharp one, but rather a gradient, influenced by a variety of factors including the initial mass of the protoplanetary disk, the presence of other forming bodies, and the gravitational forces at play. Each planetary system is a unique tapestry, woven from the threads of its own history and environment. In some systems, we find gas giants lurking closer to their stars than expected, a phenomenon known as hot Jupiters, which challenges our understanding and prompts further exploration. The story of planetary formation is also shaped by the complex interplay of gravitational forces. As planets grow, their gravitational influence increases, allowing them to clear their orbits of debris and attract additional material. This process, known as planetary migration, can lead to dramatic shifts in the arrangement of planets within a system. Such migrations can alter the destinies of worlds, bringing them closer to or further from their parent stars, with profound implications for their atmospheres and potential habitability. In addition to these dynamic processes, the chemical composition of the protoplanetary disk exerts a significant influence on the nature of the planets that form. The presence of various elements and compounds, in different proportions, can lead to a wide variety of planetary characteristics. For example, a disk rich in carbon might give rise to worlds with carbon-based geologies, whereas a disk with an abundance of oxygen might favor the formation of silicate-rich planets. As we continue to unravel these mysteries, the study of exoplanets offers invaluable insights. Observations of distant worlds, with their diverse range of sizes, compositions, and orbital configurations, provide a broader context for understanding our own solar system. Through methods such as spectroscopy and direct imaging, we can glean details about the atmospheres and surfaces of these planets, piecing together the puzzle of their formation. The exploration of our solar system has also yielded profound revelations. Missions to the rocky planets, such as Mars and Venus, have revealed complex geologies and volatile histories, while studies of the gas giants have uncovered intricate atmospheric dynamics and magnetic fields. These investigations have deepened our appreciation for the complexity and diversity of planetary systems, highlighting the myriad pathways that lead to the formation of worlds. As we contemplate the intricacies of planetary formation, we are reminded of the delicate balance that sustains the cosmos. Each planet, whether rocky or gaseous, is a testament to the creative forces that govern the universe, shaped by the interplay of heat, gravity, and chemistry. In this grand cosmic ballet, planets are born, evolve, and sometimes even die, leaving behind traces of their existence in the form of asteroids, comets, and meteoroids. This continuous cycle of creation and destruction is a reminder of the transient nature of the universe, where change is the only constant. Yet, within this impermanence, we find a profound sense of connection, as the same elements that form the stars and planets also make up the very fabric of our being. We are, in essence, stardust, intricately linked to the cosmos in ways that transcend time and space. As you ponder these celestial wonders, consider the journey of our own planet, Earth. It is a rocky world born from the remnants of ancient stars, shaped by the forces of gravity and time. Its surface teems with life, sustained by the delicate balance of elements and energy that define its environment. In the vastness of space, Earth is but a speck, yet it is our home, a cradle of life in the infinite expanse of the universe. In reflecting on the nature of rocky and gaseous planets, we gain a deeper appreciation for the complexity and beauty of the cosmos. Each world, with its unique composition and history, contributes to the rich tapestry of the universe, a testament to the creative forces that shape all things. As we continue to explore and discover, may we hold this sense of wonder close, carrying it forward in our quest to understand the mysteries of the cosmos and our place within it. In this journey of discovery, let us remain ever curious, ever humble, and ever mindful of the interconnectedness of all things. As we gaze upon the stars, may we find inspiration in their constancy and guidance in their light, allowing them to illuminate our path as we seek to unravel the secrets of the universe. For in the end, it is this spirit of exploration and curiosity that defines us, guiding us ever onward in our quest to understand the cosmos and our place within its vast, mysterious expanse. In the quiet dance of the cosmos, planetary bodies emerge, each a unique symphony of matter and energy. As we extend our gaze beyond our own celestial neighborhood, we uncover a mesmerizing diversity among these worlds. Some are solid and dense, like the terrestrial planets we are familiar with, while others are vast and ethereal, composed largely of swirling gases. This dichotomy of rocky and gaseous planets invites us to ponder the forces that shape them and the conditions that lead to such striking differences. The interplay of gravity, temperature, and material distribution in the protoplanetary disk plays a crucial role in determining a planet's fate. Closer to the star, where the warmth is more intense, only metals and silicates remain stable, coalescing into rocky planets. Farther out, where the chill of space prevails, gases and ices can accumulate, giving birth to the gas giants. Yet, there is more to this celestial ballet than mere temperature gradients. Consider the role of planetary atmospheres, which cloak these worlds in layers of gas, providing both protection and mystery. On rocky planets, atmospheres can be thin and fragile or thick and enveloping, influencing surface conditions in profound ways. Earth's atmosphere, for instance, is a delicate balance that sustains life, with its precise mix of nitrogen, oxygen, and trace gases. In contrast, Venus presents a cautionary tale, with an atmosphere so dense and rich in carbon dioxide that it traps heat in a runaway greenhouse effect, rendering its surface inhospitable. Mars, once possibly more Earth-like, now possesses a tenuous atmosphere, offering insights into atmospheric loss and planetary evolution. Gas giants, on the other hand, boast atmospheres that are not mere veneers, but rather constitute most of the planet's mass. These atmospheres are dynamic realms, with turbulent winds, complex weather patterns, and colossal storms that can rage for centuries. The Great Red Spot on Jupiter is a testament to this, a swirling tempest larger than Earth itself, persisting through the ages as both a spectacle and a mystery. Peering deeper into the composition of these planets, we find that the elemental makeup of the protoplanetary disk leaves an indelible mark. Each element has its own story, told through the lens of cosmic chemistry. The heavier elements, forged in the hearts of stars, congregate inward, forming the rocky cores of planets. Lighter elements, such as hydrogen and helium, are more plentiful but require the mass of a giant planet to be gravitationally bound in large quantities. This elemental partitioning not only dictates the planet's structure, but also its potential for hosting life. Water, a seemingly simple molecule, becomes a crucial factor in the habitability of a planet. On Earth, water's presence is vital, not only as a solvent for biochemical processes, but also as a regulator of climate. In the icy moons of the outer planets, subsurface oceans hidden beneath layers of ice offer tantalizing possibilities for life beyond Earth. As we turn our attention to the myriad of exoplanets discovered in recent years, our understanding of planetary formation and diversity expands exponentially. These distant worlds, orbiting stars far from our own, present a vast array of characteristics, some familiar, others entirely novel. We find super-Earths, larger and more massive than our own planet, straddling the line between terrestrial and gaseous. There are also mini-Neptunes, smaller versions of our solar system's ice giants, with thick atmospheres shrouding mysterious cores. The discovery of these worlds challenges our assumptions and encourages us to refine our models of planetary formation. In this grand exploration of the universe, technology plays a pivotal role, a bridge between the known and the unknown. Telescopes, both ground-based and spaceborne, extend our vision, allowing us to peer deeper into the cosmos than ever before. Instruments sensitive to different wavelengths of light reveal the compositions and atmospheres of distant planets, even hinting at the presence of clouds or hazes. The study of planetary transits, where a planet passes in front of its star, provides clues about size, orbit, and atmospheric components. Meanwhile, the Doppler effect allows us to detect the gravitational wobbles of stars, inferring the presence of orbiting planets. These techniques, combined with the ever-increasing capabilities of computers to simulate complex astrophysical processes, enable us to unravel the intricate dance of planetary systems. Yet, as we gather data and refine our theories, we remain humble in the face of the cosmos' vastness. Each discovery prompts new questions. Each answer leads to further inquiry. The universe, in its grandeur, remains a realm of endless possibilities, a testament to the boundless creativity of nature. As we contemplate the diversity of planets, we are reminded of the fragility and uniqueness of our own world. Earth, with its perfect blend of conditions, is our cradle, our home. It is a precious oasis in the expanse of space, a place where life has emerged and flourished in myriad forms. In our quest to understand the cosmos, we are also driven by the profound implications of finding life beyond our planet. Such a discovery would not only revolutionize our understanding of biology, but also our place in the universe. It would affirm the notion that life is not an isolated phenomenon, but a natural outcome of cosmic processes. As we search for biosignatures, the chemical markers of life, we do so with a sense of wonder and humility, aware that the universe is vast and full of surprises. As we continue to explore, we are guided by the spirit of collaboration and shared purpose. Space exploration is a unifying endeavor, transcending borders and cultures, reminding us of our common humanity. It is a testament to what we can achieve when we work together, driven by curiosity and a desire to learn. The challenges are great, but so too are the rewards, as each discovery enriches our understanding and inspires future generations. In this journey, we are not alone. The universe is teeming with potential, with billions of stars, each a sun to its own system of worlds. As we peer into the night sky, we are connected to this cosmic tapestry, a part of something far greater than ourselves. We are stardust, born of the universe and destined to explore its wonders. In this exploration, we find not just knowledge, but meaning, a sense of place within the cosmos, and a renewed appreciation for the planet we call home. With each step forward, we are reminded of the beauty and complexity of the universe, a reminder that there is always more to learn, more to discover. The journey of exploration is an eternal one, a journey that beckons us to continue seeking, to continue asking the questions that drive us to understand the world around us. In this quest, we find purpose, a purpose that unites us in our shared pursuit of knowledge and our desire to unravel the mysteries of the universe. As we look to the stars, we are reminded of the infinite possibilities that lie before us and the endless journey that awaits. In contemplating the infinite possibilities that lie before us, we find ourselves drawn to the fundamental question of how the universe orchestrates the symphony of its celestial bodies. The distinction between rocky and gaseous planets invites us to consider the processes that govern their formation and evolution. At the heart of this cosmic differentiation lies the concept of the protoplanetary disk, a swirling plain of dust and gas encircling a newborn star. Within this primordial nursery, the seeds of planets are sown, as particles of dust collide and coalesce, gradually forming larger bodies known as planetesimals. In the inner regions of this disk, where temperatures soar, rocky planets begin to take shape from metals and silicates, materials that can withstand the intense heat. Meanwhile, further out, where cooler conditions prevail, gas giants emerge, capturing vast envelopes of hydrogen and helium, the lightest and most abundant elements in the universe. The delicate dance of gravity plays a crucial role in this grand orchestration, guiding the assembly of these diverse worlds. As a planet grows, its gravitational pull strengthens, allowing it to gather more material from its surroundings. In the case of gas giants, this gravitational influence extends to the capture of substantial atmospheres, which envelop their cores and define their gaseous nature. The gravitational forces that shape these planets also determine their fate, influencing their orbits and interactions with neighboring celestial bodies. As we peer into the depths of space, we recognize that these forces are not static, but rather dynamic, shaping the evolution of planetary systems over billions of years. The study of exoplanets, planets beyond our solar system, has expanded our understanding of these processes, revealing a universe rich with diversity and complexity. With the aid of advanced telescopes and observational techniques, we have identified a multitude of planetary systems, each with its own unique configuration. Some systems challenge our preconceptions, with planets orbiting their stars in unexpected patterns or existing in environments vastly different from our own. This growing catalog of exoplanets underscores the adaptability of planetary formation processes, highlighting the myriad ways in which worlds can manifest. Among the most intriguing discoveries are those of planets residing in the so-called habitable zone, where conditions may allow for the presence of liquid water, a crucial ingredient for life as we know it. These findings spur our imagination and fuel the search for extraterrestrial life, a pursuit that speaks to our inherent curiosity and desire to understand our place in the cosmos. The potential for life beyond Earth invites us to consider the broader implications of our discoveries and the possibility that we are not alone in the universe. In this exploration, technology serves as both a tool and a testament to human ingenuity. The development of space-based observatories and sophisticated instruments empowers us to peer deeper into the universe, capturing the faint light of distant worlds and deciphering the information it carries. Through spectroscopy, we can analyze the compositions of exoplanetary atmospheres, seeking signatures of elements and molecules that hint at the presence of life. This technological prowess, born of collaboration and innovation, exemplifies the spirit of exploration that defines our species. As we delve deeper into the mysteries of planetary formation, we are reminded of the interconnectedness of all things. The processes that govern the birth and evolution of planets are not isolated events, but are intricately linked to the stars around which they orbit and to the broader cosmic environment. Stellar winds, magnetic fields, and cosmic radiation all play roles in shaping planetary systems, influencing their structures and the potential for habitability. This web of interactions underscores the complexity of the universe and the delicate balance that sustains it. In reflecting on these cosmic processes, we are drawn to the notion of time, a vast and unyielding continuum that stretches beyond our comprehension. The formation of planets and the evolution of planetary systems occur over immense timescales, far exceeding the span of a human lifetime. Yet, it is within this temporal expanse that we find a sense of continuity, a reminder that the universe is in a constant state of flux, perpetually evolving and reshaping itself. This perspective invites us to appreciate the fleeting nature of our own existence, while also recognizing the enduring impact of our quest for knowledge. The search for understanding is, at its core, a journey of discovery, one that transcends the boundaries of individual disciplines and unites us in a shared pursuit. Scientists from diverse fields collaborate to piece together the puzzle of planetary formation, drawing on insights from astronomy, geology, chemistry, and physics. This interdisciplinary approach enriches our understanding, offering new perspectives and fostering innovation. It is a testament to the power of collective endeavor, demonstrating that the pursuit of knowledge is a communal enterprise, one that benefits from the contributions of many. As we continue to explore the cosmos, we are guided by the principle of humility, recognizing that our understanding is but a fragment of a much larger picture. The universe is vast and enigmatic, and there is much that remains beyond our grasp. Yet, it is this very mystery that propels us forward, driving us to ask questions and seek answers. In acknowledging the limits of our knowledge, we open ourselves to new possibilities, embracing the unknown as an opportunity for growth and discovery. In contemplating the nature of planets and the forces that shape them, we are reminded of the beauty and complexity of the universe. Each world, whether rocky or gaseous, is a unique expression of the cosmic processes that govern its formation. These planets, in their diversity, reflect the richness of the universe itself, offering a glimpse into the myriad ways in which matter can organize and structure itself. As we study these celestial bodies, we are inspired by their grandeur and complexity, and we are reminded of the wonder that first drew us to the stars. In this journey of exploration, we find a sense of purpose, a calling to seek out the unknown and to expand the horizons of human understanding. The pursuit of knowledge is a noble endeavor, one that transcends the limitations of time and space, connecting us to the broader tapestry of the cosmos. As we look to the future, we are filled with a sense of hope and possibility, confident that the journey will continue, guided by the light of curiosity and the desire to understand our place in the universe. Let us cherish the beauty of the cosmos and the insights it offers, for in doing so, we honor the spirit of exploration that defines us. As we gaze at the stars, we are reminded of the infinite possibilities that lie before us, and the endless journey that awaits, a journey that invites us to dream, to wonder, and to seek the secrets that the universe holds. In this quest, we are united in our shared pursuit, bound by a common desire to understand the world around us and to unravel the mysteries of the universe. The cosmos beckons, and we are compelled to answer its call, driven by the timeless allure of discovery and the promise of new horizons. The universe, in all its splendor, awaits our exploration, offering a canvas for our imagination and a stage for our journey into the unknown. In the vast expanse of the universe, where stars are born and galaxies dance in a cosmic ballet, we find ourselves drawn to the planets, each a world unto itself, shaped by the forces of nature and time. These celestial bodies, with their unique compositions and characteristics, tell stories of creation and transformation that have unfolded over billions of years. As we contemplate the nature of rocky planets and their gaseous counterparts, we uncover a tale of elemental diversity and cosmic evolution, a narrative that is both intricate and sublime. The rocky planets, such as Earth and Mars, are the solid sentinels of the inner solar system. Composed predominantly of silicates and metals, these planets have formed closer to the warmth of their parent stars, where the heat of the nascent sun vaporized lighter elements, allowing only heavier materials to coalesce. These terrestrial planets are marked by their solid surfaces, tectonic activity, and the presence of mountains, valleys, and craters that bear witness to the relentless passage of time. On Earth, we find a delicate balance of elements that has nurtured life, a testament to the unique conditions that have allowed life forms to flourish in a complex web of ecosystems. In contrast, the gaseous giants like Jupiter and Saturn reside in the cooler regions of the solar system, where the primordial materials could condense into vast atmospheres of hydrogen and helium. These behemoths, lacking a definitive solid surface, are characterized by their swirling clouds and powerful storms, with winds that rage at incredible speeds. Their immense size and mass exert a significant influence on the architecture of the solar system, their gravity shaping the orbits of moons and asteroids, and their magnetic fields creating vast belts of radiation. These gas giants are not only fascinating in their own right, but also serve as natural laboratories for studying atmospheric dynamics and planetary formation. As we peer deeper into the cosmos, we encounter the ice giants, Uranus and Neptune, which occupy the farthest reaches of our solar system. These planets, shrouded in mystery, consist of heavier volatile substances like water, ammonia, and methane, which form icy mantles surrounding rocky cores. The azure hue of Neptune and the pale blue of Uranus speak to their unique atmospheric compositions, where complex chemical interactions occur in the frigid cold. These distant worlds challenge our understanding of planetary science, offering hints of processes that operate on scales and under conditions vastly different from those on Earth. The study of these planets is not merely an academic pursuit, but a journey into the fundamental nature of matter and energy. Through the lens of astronomy and planetary science, we gain insights into the processes that govern the universe, from the formation of stars to the birth of planets and the emergence of life. The interplay of heat, pressure, and chemistry in these celestial environments reveals the delicate balance that sustains planetary systems, a balance that is reflected in the harmony of the solar system and the intricate dance of its inhabitants. Our exploration of the cosmos is driven by both curiosity and a deep-seated desire to comprehend our origins. As we look to the planets, we are reminded of the interconnectedness of all things, from the smallest atom to the largest galaxy. This interconnectedness is manifest in the elements that make up the planets, elements forged in the hearts of stars and scattered across the universe by the force of supernovae. These building blocks of matter, the carbon, oxygen, silicon, and iron, are the same elements that form the foundation of life on Earth, binding us to the stars and the cosmos in a profound way. The search for other worlds, for planets that might harbor life, is a quest that engages both the mind and the imagination. With each new discovery, we expand the boundaries of what we know and challenge the assumptions that have shaped our understanding of the universe. The detection of exoplanets in distant star systems, some of which lie within the habitable zones of their stars, has fueled speculation about the potential for life beyond Earth. These planets, with their diverse compositions and climates, present tantalizing possibilities for the existence of life in forms and environments that may be vastly different from our own. In our quest to understand the cosmos, technology serves as both our guide and our instrument. Advances in telescopes and imaging technologies have allowed us to peer into the farthest reaches of space, capturing the light of distant stars and the shadows of their orbiting planets. Spectroscopy, the study of light and its interactions with matter, enables us to probe the atmospheres of these distant worlds, searching for chemical signatures that might indicate biological activity. This pursuit of knowledge is a testament to human ingenuity and perseverance, a reflection of our relentless drive to explore and understand the universe in which we live. The exploration of space is not solely the domain of scientists and researchers, but a shared endeavor that engages all of humanity. It is an invitation to reflect on the nature of our existence, to ponder the questions that have captivated our collective imagination for millennia. What is life, and how did it arise? Are we alone in the universe, or is life a common thread that weaves through the fabric of the cosmos? These questions resonate with a timeless significance, drawing us into a dialogue with the universe that transcends the boundaries of time and space. As we contemplate the cosmos, we are reminded of the fragility and resilience of life on Earth. Our planet, a small blue dot in the vastness of space, is a sanctuary for life, a place where the conditions have aligned to create a thriving biosphere. The study of other planets with their harsh and inhospitable environments underscores the preciousness of our own world and the responsibility we have to protect and preserve it for future generations. The exploration of space, with all its challenges and opportunities, is a journey of discovery that enriches our understanding of life and our place in the universe. In the silence of the night sky, where the stars twinkle like distant beacons, we find a reflection of our own journey, a journey marked by exploration, discovery, and a profound sense of wonder. The planets, in their diversity and beauty, inspire us to dream and to reach for the stars, to seek out new worlds and new possibilities. The universe, vast and mysterious, is a canvas on which the story of life is painted, a story that unfolds with each new discovery and each new insight into the nature of reality. In this cosmic journey, we are both observers and participants, creators of knowledge and explorers of the unknown. The universe, in all its complexity and grandeur, beckons us to explore its depths, to unlock its secrets, and to embrace the wonder of existence. It is a journey that has no end, a journey that continues to unfold with each passing moment, as we look to the stars and imagine the possibilities that await us in the vast and infinite cosmos. This eternal dance of exploration guides us through the celestial tapestry, where each star and planet is a note in the grand symphony of the universe. As we journey further, we find ourselves contemplating the delicate balance between the familiar and the unknown. Our solar system, with its diverse array of planets, moons, and other celestial bodies, serves as a rich tapestry of mysteries waiting to be unraveled. Each entity within it, from the tiniest asteroid to the mightiest gas giant, holds clues about the formation and evolution of our cosmic neighborhood. It is through the study of these varied worlds that we begin to piece together the history of our own planet, understanding how Earth came to be a cradle for life amidst the cold vastness of space. Turning our gaze towards the stars, the search for exoplanets continues to captivate our imagination. These distant worlds, circling stars far beyond our own, are potential havens for life, each one a new chapter in the story of the cosmos. The technological advancements that allow us to discover these planets, such as the precision of transit photometry or the subtle shifts in stellar light caused by radial velocity, are feats of human ingenuity. They enable us to peer into the atmospheres of these alien worlds, searching for signs of habitability or even life itself. Through these observations, we gain insight into the myriad ways planetary systems can form and evolve, expanding our understanding of the diverse possibilities for life beyond Earth. The variety of planetary compositions we observe, from rocky terrains to gaseous expanses, prompts further inquiry into the forces that shape these celestial bodies. The interplay of gravity, temperature, and material composition during the formation of a solar system determines the fate of its planets. In the early stages, a swirling disk of gas and dust surrounds a newborn star, gradually coalescing into planets. Within this protoplanetary disk, temperature gradients play a crucial role. Closer to the star, where it is warmer, only heavier elements and compounds can condense, giving rise to rocky planets. Further out in the cooler reaches, lighter gases like hydrogen and helium can accumulate in large quantities, leading to the formation of gas giants. This understanding of planetary formation is fundamental to our comprehension of the cosmos. It tells a tale of balance and harmony, where the conditions within a solar system influence the characteristics of its planets. It also highlights the diversity of planetary systems, each with its own unique configuration and history, shaped by the delicate dance of cosmic forces. As we continue to explore these distant worlds, we are reminded of the interconnectedness of all things, the way in which the same physical laws govern both the smallest grain of dust and the largest gas giant. The mysteries of the universe are not confined to the planets alone. Moons, asteroids, and comets also play significant roles in our cosmic narrative. These smaller bodies, often overlooked, hold secrets about the early solar system, their surfaces scarred with the impacts of time. Moons, in particular, offer fascinating possibilities. Some, like Europa and Enceladus, are believed to harbor subsurface oceans beneath their icy crusts, raising intriguing questions about the potential for life in these hidden waters. The presence of liquid water, combined with the chemical interactions that occur within these oceans, suggests that these moons could be among the most promising places to search for extraterrestrial life within our own solar system. The study of these celestial bodies not only enhances our understanding of planetary science, but also deepens our appreciation for the intricate beauty of the universe. Each discovery, each piece of data collected, adds to the mosaic of knowledge we are painstakingly assembling. It is a process that requires patience and perseverance, as well as a willingness to embrace the unknown. For every answer we find, new questions emerge, propelling us ever forward in our quest for understanding. This quest is not merely an academic pursuit. It is a reflection of our innate curiosity, our desire to know and to explore. It speaks to the very essence of what it means to be human, our drive to transcend the boundaries of our immediate surroundings and to seek out the wonders that lie beyond. In doing so, we are reminded of our place in the universe, a small but significant part of a much larger whole. As we venture further into the cosmos, the tools we employ become ever more sophisticated. Spacecraft and telescopes, both ground-based and orbiting, provide us with unprecedented views of distant worlds. Missions like those to Mars or the outer planets bring back data that refine our models and challenge our assumptions. These technological marvels are testament to human ingenuity and the collaborative spirit that drives scientific advancement. Yet, even as we push the boundaries of exploration, we must also consider the ethical implications of our actions. The preservation of celestial environments, the avoidance of contamination, and the respectful treatment of the extraterrestrial landscapes we visit are crucial considerations. As stewards of our own planet, it is our responsibility to extend this care to the cosmos, ensuring that our exploration leaves no harmful legacy. This sense of stewardship is closely tied to the larger questions of existence and purpose. In pondering the vastness of space, we are confronted with the fragility of our own world. The Earth, with its complex ecosystems and delicate balance, is a rare and precious haven in the vast expanse of the universe. Our efforts to explore and understand the cosmos are, in part, driven by the desire to protect and preserve this unique planet that we call home. In this light, the study of other worlds becomes not just a scientific endeavor, but a deeply philosophical one. It prompts us to reflect on our values, our priorities, and our vision for the future. It challenges us to think about how we can live in harmony with our environment, both on Earth and in the broader universe. As you listen to this narration, imagine the journey of a photon of light traveling across the cosmos through the vast interstellar medium until it reaches the lens of a telescope on Earth. This simple journey, repeated billions of times over, brings with it the stories of stars and planets, of galaxies and nebulae. It is a journey that connects us to the universe, reminding us of the intricate web of existence that binds us all. In this grand exploration, the universe becomes a mirror, reflecting back our own curiosity and wonder. It invites us to ponder the nature of life, the possibilities of other realities, and the beauty of the unknown. As we continue to reach for the stars, we carry with us the hope that our discoveries will enrich our understanding, not just of the cosmos, but of ourselves. The night sky, with its myriad points of light, serves as a constant reminder of the vastness of the universe. It is a canvas upon which we project our dreams and aspirations, a source of inspiration and awe. In its quiet majesty, it calls to us, urging us to look beyond the confines of our everyday lives and to embrace the infinite possibilities that await. This narrative of discovery and exploration is one that unfolds with each passing day, as we continue to push the boundaries of knowledge and reach for new horizons. It is a journey that is both personal and collective, one that unites us in a shared quest for understanding. In the end, it is a testament to the enduring spirit of humanity, our capacity for wonder, and our relentless pursuit of knowledge. As you contemplate these thoughts, allow yourself to be enveloped by the tranquility of the cosmos. Imagine the serene expanses of interstellar space, the gentle glow of distant galaxies, and the silent dance of planets and stars. In this vastness, there is a sense of peace, a reminder of the continuity of existence and the unending cycle of discovery. And so we journey onward, guided by curiosity and wonder, ever seeking, ever learning, and ever inspired by the beauty and mystery of the universe. With each step, we deepen our connection to the cosmos, enriching our lives and expanding our horizons. This is the essence of exploration, a journey without end, filled with endless possibilities and the promise of new discoveries. In this quiet contemplation of the universe, we find ourselves drawn to the very essence of what makes a planet rocky or gaseous, a question that speaks to the fundamental processes at the heart of planetary formation. In the early solar system, a swirling disk of gas and dust orbited the nascent sun, a chaotic and dynamic environment where particles clung together, forming ever larger bodies. In the inner regions, where the warmth of the sun's early heat was most intense, lighter gases were less likely to condense. Here, rocky planets began to take shape, their compositions rich with metals and silicates, elements that could withstand the solar heat. Mercury, Venus, Earth, and Mars emerged from these conditions, each molded by the intricate dance of gravity and chemistry. Beyond this realm where solar warmth waned, the composition of planets shifted dramatically. Here, in the cooler reaches of the solar nebula, gases like hydrogen and helium could condense onto the solid cores that had formed, swelling into the vast and majestic gaseous giants we observe today. Jupiter and Saturn, enormous and enveloped in dense atmospheres, owe their existence to these cooler, distant birthplaces. Their grandeur is a testament to the abundance of lighter elements in the outer solar system, forming a stark contrast to the rocky worlds closer to the sun. The architecture of our solar system, with its inner rocky planets and outer gaseous giants, is a reflection of these early conditions, a lasting imprint of the processes that govern the birth of worlds. Yet, even as we look upon this familiar arrangement, the discovery of exoplanets has revealed a stunning diversity that challenges our understanding. Planetary systems around other stars display a vast array of configurations, some with gas giants orbiting perilously close to their stars, known as hot Jupiters, others with rocky worlds in distant, frigid orbits. These findings compel us to reconsider the boundaries of planetary formation and the myriad ways in which planets can arise. As we expand our gaze beyond the solar system, we are reminded of the importance of water, a vital ingredient for life as we know it, and its role in shaping planetary environments. On Earth, water is a cornerstone of life, a solvent and medium for biochemical processes. The search for life beyond our planet often begins with the search for water, whether in the form of vast oceans, subsurface reservoirs, or even in the atmospheres of distant exoplanets. On Mars, the evidence of ancient riverbeds and lakebeds speaks to a time when water flowed freely across its surface, a tantalizing hint of a potentially habitable past. Similarly, the icy moons of Jupiter and Saturn, such as Europa and Enceladus, are believed to harbor vast subsurface oceans beneath their frozen crusts. These hidden seas, warmed by the tidal forces exerted by their parent planets, are intriguing candidates in the search for extraterrestrial life. The possibility of life thriving in such environments expands our understanding of where life might exist, beyond the traditional confines of a planet's surface. Our exploration of these distant worlds is not without profound implications. As we venture into the cosmos, we are confronted with questions about our place in the universe and our responsibilities as explorers. The discovery of potentially habitable environments raises ethical considerations about the protection and preservation of these pristine worlds. The concept of planetary protection underscores our duty to avoid contaminating other planets and moons with earthly organisms, a precaution to preserve their natural states and any potential ecosystems they may harbor. In this light, space exploration becomes a reflection of human values and priorities, a journey that challenges us to consider the long-term impact of our actions on both our planet and the cosmos. As we reach for the stars, we are reminded of the interconnectedness of all things, a delicate balance that sustains life on Earth and perhaps elsewhere in the universe. The serene beauty of the cosmos invites us to ponder the fundamental questions of existence. What is the nature of life? Are we alone in this vast expanse? These questions inspire a sense of wonder and curiosity, a desire to explore and understand the universe in all its complexity. The night sky, with its countless stars and distant galaxies, serves as a canvas for our dreams and aspirations, a reminder of the infinite possibilities that await us. In our quest for knowledge, we are guided by the light of distant stars, a journey that connects us to the cosmos in profound ways. The photons that reach our telescopes have traveled across space and time, carrying with them the stories of their origins. Each observation, each discovery, deepens our understanding of the universe and our place within it. The study of planetary atmospheres, for instance, offers insights into the chemical processes that occur on distant worlds. By analyzing the light that passes through or reflects off a planet's atmosphere, scientists can infer the presence of various gases, revealing clues about the planet's climate and potential habitability. This technique, known as spectroscopy, is a powerful tool in the search for life, as certain gases, such as oxygen and methane, can indicate biological activity. The diversity of planetary atmospheres, from the thick, crushing clouds of Venus to the thin, wispy layers of Mars, highlights the complex interplay of physical and chemical processes that shape a planet's environment. These atmospheres are shaped by a multitude of factors, including the planet's distance from its star, its size and composition, and its geological activity. The study of these factors not only enhances our understanding of individual planets, but also informs our knowledge of planetary evolution as a whole. The search for life beyond Earth is a quest that transcends scientific inquiry, touching on philosophical and existential questions about the nature of life and our place in the universe. As we seek to answer these questions, we are reminded of the importance of humility and open-mindedness, recognizing that life may take forms and exist in environments that challenge our preconceptions. In this endeavor, we are guided by the principles of scientific exploration, a commitment to evidence-based inquiry and the pursuit of truth. The scientific method, with its emphasis on observation, experimentation, and analysis, provides a framework for understanding the natural world and our place within it. It is a tool that empowers us to explore the cosmos with curiosity and rigor, seeking answers to the mysteries that surround us. The wonder of the universe lies not only in its vastness and complexity, but also in its ability to inspire and uplift. As we gaze upon the stars, we are reminded of our shared humanity, a connection that transcends boundaries and unites us in our quest for knowledge. The exploration of space is a collective endeavor, a testament to the power of collaboration and the spirit of discovery. In this journey, we are called to embrace the unknown, to venture into the uncharted territories of the cosmos with courage and curiosity. The universe beckons with its mysteries, inviting us to explore and understand the wonders that lie beyond our world. It is a journey that enriches our lives, expanding our horizons and deepening our connection to the cosmos. As we continue to explore the universe, we are reminded of the importance of stewardship and responsibility. Our actions have the potential to shape the future of space exploration, influencing the legacy we leave for future generations. In this light, we are called to consider the impact of our endeavors on both the Earth and the cosmos, striving to preserve and protect the environments we encounter. The universe, with its infinite expanse and boundless possibilities, is a source of inspiration and wonder. As we journey through the cosmos, we are invited to reflect on the nature of existence and our place within the grand tapestry of creation. It is a journey that challenges us to look beyond the confines of our daily lives, to embrace the mysteries of the universe with open hearts and minds. In this vast and wondrous expanse, we find a sense of peace and continuity, a reminder of the unending cycle of discovery and the promise of new horizons. The journey of exploration is one without end, a testament to the enduring human spirit and our insatiable curiosity. As we seek to understand the universe, we are reminded of the beauty and mystery that surrounds us, a source of inspiration and awe that enriches our lives and expands our understanding of the cosmos. With each step we take, we deepen our connection to the universe, exploring the wonders that lie beyond our world. It is a journey that invites us to embrace the infinite possibilities that await, guided by the light of distant stars and the spirit of discovery. As we continue this journey, we are reminded of the interconnectedness of all things, a reflection of the cosmic dance that shapes the universe and our place within it. The universe is a vast and wondrous expanse, a source of inspiration and wonder that beckons us to explore and understand its mysteries. It is a journey that enriches our lives, expanding our horizons and deepening our connection to the cosmos. As we embark on this journey, we are reminded of the beauty and mystery that surrounds us, a source of inspiration and awe that transcends the boundaries of time and space. In the quiet contemplation of the cosmos, we find a sense of peace and continuity, a reminder of the unending cycle of discovery and the promise of new horizons. The journey of exploration is one without end, a testament to the enduring human spirit and our insatiable curiosity. As we seek to understand the universe, we are guided by the light of distant stars, a journey that connects us to the cosmos in profound ways. It is a journey that invites us to embrace the infinite possibilities that await, guided by the light of distant stars and the spirit of discovery. The vastness of the universe unfolds in myriad ways, each star and planet a silent testament to the complex forces at play in the cosmos. As we ponder the diversity of planets, we find ourselves drawn to the fundamental differences that define their very nature. Some worlds, like our Earth, are solid and rocky, their surfaces enduring the slow, patient sculpting of geological processes. Others, like Jupiter and Saturn, are vast realms of swirling gas, their majestic bands and storms painting a picture of dynamic atmospheres in constant motion. These distinctions invite us to explore the underlying principles that govern the formation of such varied worlds. In the earliest moments of our solar system, a swirling disk of gas and dust spun around the nascent sun. Within this protoplanetary disk, a delicate dance of particles began, guided by gravity's gentle yet inexorable pull. The inner regions, bathed in the warmth of the young sun, saw the aggregation of heavier elements, such as iron and silicon, which coalesced to form the rocky bodies of the terrestrial planets. Mercury, Venus, Earth, and Mars emerged as solid worlds, their surfaces shaped by volcanic activity, tectonics, and the slow accumulation of impacts from space. Further out, where the sun's heat waned, lighter elements could retain their gaseous states. Here, in the cooler reaches of space, the gas giants came into being. Jupiter and Saturn, with their thick atmospheres of hydrogen and helium, grew massive, drawing in substantial amounts of surrounding gas. It is within this environment that their vast, swirling atmospheres were born, creating complex systems of storms and winds, their subtle hues reflecting the intricate chemistry of their skies. The formation of gas giants is a reminder of the delicate balance of forces that shape the cosmos. Their immense gravitational pull allowed them to capture and hold onto these lighter elements, a process that smaller, rocky planets could not achieve. This gives rise to the striking dichotomy we observe, with these colossal worlds standing as sentinels in the outer solar system, their presence a testament to the diversity of planetary formation. As we gaze upon these gaseous behemoths, we ponder the mysteries that lie within. Beneath their clouds, hidden from our view, are cores that may be rocky or icy, their composition still a matter of scientific inquiry. The distinction between rocky and gaseous worlds is not merely a question of surface features, but of the complex interplay of materials, temperature, and gravitational forces that dictate the destiny of each planet. The gas giants, with their multitude of moons, offer yet another layer of complexity. These natural satellites, each with their own unique characteristics, contribute to the intricate dance of celestial mechanics. Some, like Jupiter's moon Europa, intrigue us with the possibility of subsurface oceans, potentially harboring conditions conducive to life. Others, like Saturn's Titan, present alien landscapes of liquid methane lakes and rivers, a reminder of the diverse environments that exist beyond our home planet. In contemplating the differences between rocky worlds and their gaseous counterparts, we find ourselves drawn into questions of habitability and the conditions necessary for life. Earth, with its life-sustaining atmosphere and abundance of water, remains a singular example in our search for life beyond our planet. Yet, the study of other worlds, each with its own defining characteristics, enhances our understanding of the potential for life in the universe. The exploration of these diverse worlds is not simply a pursuit of knowledge, but a journey of understanding the place of life in the cosmos. It is a reminder that each planet, whether rocky or gaseous, contributes to the rich tapestry of the universe, each playing a role in the grand cosmic narrative. As we continue to unravel the mysteries of planetary formation, we deepen our connection to the universe and our understanding of the forces that shape these celestial bodies. The quiet beauty of this diversity invites reflection on the nature of existence itself. With each discovery, we gain a deeper appreciation for the delicate balance that allows planets to form and evolve, a balance that speaks to the intricate workings of the cosmos. It is in this exploration that we find a sense of wonder, a gentle curiosity that drives us to look beyond the familiar and embrace the unknown. There is a profound tranquility in contemplating the vastness of space and the myriad worlds that inhabit it. Each planet, whether composed of rock or gas, holds its own story, a chronicle of formation and evolution that has unfolded over billions of years. These stories, written in the language of the stars, remind us of the interconnectedness of all things, each world a piece of the cosmic puzzle, each contributing to the larger story of the universe. As we draw our thoughts inward, we find a gentle resonance with the rhythm of the cosmos. The planets in their silent orbits reflect the harmony of celestial mechanics, a dance that has continued for eons. In this quiet harmony, we find a sense of peace, a reminder of our place within the cosmic order. The diversity of planets, with their rocky surfaces and gaseous expanses, speaks to the creativity of the universe, a creativity that is mirrored in the diversity of life on Earth. The exploration of these worlds, with their varying compositions and atmospheres, reminds us of the enduring nature of curiosity and discovery. It is a journey that invites us to look beyond the horizon, to seek understanding in the unknown, and to embrace the infinite possibilities that the universe offers. In this pursuit, we find a sense of continuity, a connection to the stars that have guided explorers for generations. As we reflect on the nature of these planets, we are reminded of the delicate interplay of forces that shape the cosmos. It is a reminder that the universe is a place of infinite variety and beauty, a place where each planet, each star, and each moment is part of a larger, interconnected whole. This understanding brings with it a sense of tranquility, a gentle acceptance of the mysteries that remain, and a quiet appreciation for the journey of discovery that lies ahead. In the vast expanse of space, the diversity of planets inspires a sense of wonder, a gentle curiosity that invites us to explore and understand. It is a journey that connects us to the stars, to the cosmos, and to each other, a journey that is as much about the exploration of the universe as it is about the exploration of ourselves. As we look to the stars, we find a reflection of our own journey, a journey that continues to unfold, guided by the light of distant stars and the spirit of discovery. This profound connection invites us to ponder the subtle forces that shape not only the planets, but also the very fabric of the universe. As we contemplate these cosmic wonders, we find solace in the delicate balance and intricate dance of celestial bodies, each orbiting in silent harmony. The whisper of the solar winds and the gentle pull of gravity create a symphony that resonates through the vastness of space, reminding us of our place within this grand tapestry. Our journey into the cosmos is not merely a voyage outward, but also a journey inward, where we embrace the mysteries that lie within. In the quietude of this exploration, we find ourselves gently cradled by the universe, a part of its endless story, woven into the stardust from which we all came, and to which we will always belong.